we are looking at 6-7, called the Arithmetic and Geometric Sequence. Now, we always go around and around and teachers, I'm like, is it called arithmetic? Because when you look at it, arithmetic. But whenever we talk about sequences, I've always heard it as arithmetic sequence, arithmetic sequence. So however you pronounce it is fine. But we're going to look at the differences. We're going to look at arithmetic sequence or the other one, geometric sequence. Geometric. So arithmetic, what that means is you're either adding or subtracting to get the next number. So a sequence is a pattern or an order. So when we have the numbers 3, 5, 7, here's our first term, here's our second, here's our third. What's happening to get from the first to the second, from the second to the third? Well, it's adding 2 each time. So with the arithmetic sequence, this is when you're adding or subtracting to get to the next numbers. Okay, so arithmetic is adding or subtracting. Now, we call this, when you have the same thing that you're adding or subtracting, this is going -2 to -5 to -8, you're going down by 3, so you're subtracting. We call that a common difference. And we use a D to represent that. And in between any two consecutive numbers, probably should numbers be there, it can be positive or negative. So the common difference can be subtracting 3 or adding 2. Okay, so arithmetic sequence. Now we're going to identify arithmetic sequence. We're going to see if they are arithmetic or not. So looking at from 1 to 5 to 9 to 13. Well, if I add 4 here, add 4, yes. This is arithmetic sequence. If yes, identify the common difference. So this one, the D would equal a positive 4. Okay, so let's look at this one. This looks like it's adding 2, adding 3. Do not just stop at the first 2, because usually this is what happens. The last one, something's different. So this is not an arithmetic sequence. This is actually a different type of sequence, which we'll talk about hopefully later. This one, 8, 6, 4, so it's going down. It's going down by 2, going down by 2, going down by 2, yes. So the common difference is a -2. You're subtracting 2. This one, -3, yes, the common difference is a -3. This one, 5 to 10, that's plus 5, plus 5 or times 2, Okay, this is not arithmetic, even though there's a sequence, it's not arithmetic. So this is no. We're going to actually learn next page what that is. So the next one, yeah, sorry, that was blurry. So this is going down by 1, down by 1, down by 1, yes. So it's going to be a -1, okay? So those differences, if it's not adding or subtracting, if it's not a common difference, it's not a arithmetic sequence. Now let's continue the arithmetic sequences. So given the arithmetic sequence, find the next 3 terms. Well, we got to look at it. It's like, you probably remember this back in, I don't know, 3rd, 4th grade, like find the next 3 numbers. So what's happening here? Let's see here. Are we adding 4, adding 4, adding 4? Yes. So 21 plus 4 is 25. 25 plus 4 is 29. 29 plus 4 is 33. Okay, so you're looking for the next 3. Now, given the arithmetic sequence, so they're telling us it's the sequence. So that's subtracting 3, subtracting 3, subtracting 3. Watch that. I lost my line there. So that's a -7, -10, -13. Okay, kind of messed up my lines. This one is -8 to, this is going up 6. Up 6, up 6. And then it's going to be 16, 22, 28, if I did all that correctly. Okay, so now, so those are great, but what happens if I say 9, and I'm going up by 4 each time, but I want to know the 100th term? If I wanted the 100th term, I sure in heck do not want to sit here and write out all the numbers from 9 to whatever for 100 numbers. 1, it takes too long, it's not efficient. Second, I have a greater chance of error. So we can use a formula to find the nth term. This is what we're talking about. So this is n equals the term number. If you ever finding the nth term, that means, well, do we want the 100th term? Do we want the 50th term? Do we want the 25th term? So our D in this formula is our common difference. We want to know what's happening. Are we adding or subtracting? And by how much? Now the A sub 1. The A sub 1, notice you have an A sub n, A sub 1, plus D, parentheses, n minus 1. The A sub 1 is your first term. So you need to know where you're starting. If I said, what's the 100th term in my sequence? You're going to go, well, what's your first term and how is your sequence changing? So we need to know this information. And then I'm going to explain what this n minus 1 represents. So write an equation for the nth term in the arithmetic sequence, 14, 11, 8, and 5. Then find a to the 50th power. That means, not the 50th power, excuse me. Notice it's a subscript, not an exponent. The subscript means we need to know the 50th term. I don't want to write out 50 numbers to get to it. So here's what you're doing. So a sub n, that means your 50th term. Your first number in the sequence. Your first number is 14 because we need to know where you're starting. You're starting at 14. What's happening now, the common difference? Well, this is going down by 3. So your common difference is negative 3. But watch what happens. Our n is your, this is your n. Your number, 50 minus 1. Why do you think we're taking 50 minus 1 here? Because I already know, yeah, you're right. You're taking the first term already. You already know the first term. So we need to know the next 49 terms to get to the 50th term. Okay? So this is your first term. First term is 14. Your 50th is going to be down here. So I need to multiply this negative 3 49 times. So I'm going to do, 14 plus negative 3 times 49, because I need to know this 49 times I'm going to be subtracting negative 3. Well, that's why it's multiplication. All multiplication is, you guys, is repeated addition or repeated subtraction. So negative 3 times 49. So now if you're using your negative, it's going to be negative, but do 3. Nope. On this calculator, you're going to do it first. Negative 3 times 49. Negative 147. So you have 14 minus 147. And then you're going to subtract that. So 14, it's going to be a negative 147. A negative, the 50th term is negative 133. Okay. Much easier, much faster, less error if you use a formula versus listing it all out. Okay. And what's great about the EOC, you guys, you're going to have a sheet with all these formulas. And I'm going to give it to you early so you can start marking it up. You can't use that sheet, but you can mark it up. Am I recording? Yes, I am. Thank gosh. So you're going to have a sheet with all these formulas, but I just want you to be able to recognize them when you get to them. All right, let's do this one. Write an equation for the nth term arithmetic sequence, 8, 16, 24, 32. Okay, then find the 25th term. Now be careful here. Okay, first of all, our first term. So we need to find our 25th term. The 25 is what number of term we're using. Our first term is 8. Now it says arithmetic. But look at it. It looks like you're multiplying. Oh, no, it doesn't look like you're multiplying by 2. Good. So you're saying plus 8, plus 8, plus 8. It looks like 8 plus 8 times 1, 8 times 2, 8 times 3. That's what it is. But make sure you do adding 8 each time. Now, we're starting at 8. We're adding 8 each time. And we need to do 25 minus 1. We only need to do this 24 times because we already know the first one. So 8 times 24, 192. 8 plus 192 is going to be 200. So the 25th term in this sequence is going to be 200. Use your formula. Don't list it all out. Use your formula. Again, first term, your common difference, and then how many terms you need but minus 1 because you already have your first one, and then just simplify it. All right? All right, so that's arithmetic sequence. Now, let's look at geometric sequence. Geometric, notice how we get from 1 to 5 to 10. Well, I could say plus 4, but that doesn't help here. Look at this. I can do 1 times, those aren't the same numbers. That's times 5 times 5. So this sequence, you're multiplying. Okay. Now, you're always going to be multiplying. Even though it might look like division, I'll show you that. So this is 1, 2, 4, 8. So we're multiplying by 2 each time. Now look at this. 54, 18, 6. It's going down. And sometimes we might not see it here, but maybe over here. 18 to 6 is it looks like you're dividing by 3. But what you're doing, we always use a multiplication. So we're going to do multiplying by 1/3. Now this is called the common ratio. because you can write this 2 over 1. You can write dividing by 3 as 1/3. So you're going to have an R in this one. It's a common ratio, and it's between two consecutive numbers or integers, whatever it is, can be positive or negative. Okay, now we're going to identify if it's geometric sequence. Again, you guys, I know I'm talking fast because I have 15 work it. Don't feel my... Sorry, I need a drink. 2, 10, 50, 250. Well, it looks like it can multiply by 5. Yes. So the common ratio, the R, is going to be 5 on this one. All right. 135 to 45. I might not see it there, but 45 to 15, 15 to 5, I can definitely see. This looks like I'm dividing by 3. And if I want to check that, I could do 135. 135 divided by 45. Yep, that's a 3. If you don't know for sure, you can take the first two numbers and then take the next two, and see if it comes out to the same. Now, it's dividing by 3, but you're not going to do dividing by 3. You're going to do 1/3. Okay, we're multiplying. So dividing by 3 is the same as multiplying by 1/3. All right, this one. Oh, that looks like multiplying by 3. Ooh, but this is not. That is not. This is not. So this is not a sequential, or excuse me, a geometric sequence. Continuing the geometric sequence, same thing. Oh, given the this needs to be geometric. Sorry, we cut and paste. So this should be a geometric. Sorry about that. We cut and paste. Find the next 3 terms. Now, be careful your signs. 7 to a negative 21, then back to a positive. So this is going to be times 3, but a negative 3 times negative 3. So that's positive. The next one needs to be negative. So 63 times 3. Sorry, guys, I'm just going to do this real quick. I know you can. Oh, yeah, 189. So this is going to be a negative 189. Now times 3, but this is going to be a positive 567. Now this next one is going to be negative, but I don't want to waste my time typing in negatives. Oh, 1701. That was my address growing up. Negative 1701. Those things just stick with you. So negative there. So just be careful because it's going every other sign. That means it's multiplying by a negative. All right. Now these, oh gosh, I don't know for sure on top of my head. So let's check it. 3072 divided by 768. I know it's going down. Okay. So this is dividing by 4. Let's see this. 768 divided by 192. 4. Okay, so it's dividing by 4. It's going down, so I know it's division, but it's multiplying by 1/4. So technically what you can do is 192 divided by 4, 48 divided by 4, 12 divided by 4 is 3. Okay, so that common ratio was 1/4. All right. This is a little easier to see. 8 to 4, that's divided by 2. 4 to 2, that's divided by 2. So the ratio is 1/2. 2 divided by 2 is 1. And be careful. 1 divided by 2, half of 1 is half. Half of half is 1/4. You're not going to a negative here. Okay, when you do this, you're not changing signs at all because you're just going to get smaller and smaller and smaller. It's going to be closer to the 0. Okay, I have 13. Let's keep going. All right, here we go. Geometric sequence. The nth term, again, this is your nth term. Whoops, term number. So, like if we want the 14th term, same thing as the arithmetic, except for we have a common ratio. So your R is your common ratio. G to the first, this is your first term. We always need to know where you're starting, or I have no idea what to do next. All right, let's see if we can get this done. We have G to the 14th, not G to the 14th, but the 14th term in the sequence. And your first term is 5 times your common difference. What's happening? You're multiplying by 4. Now notice this is an exponent. Uh-oh, this is written wrong. G to the 14th, or G to the 14th, 5 times 4. And then we need 14 minus 1 as the exponent because we only need 13 of these. So you have, I'm going to run out of time, 5 times 4 to the 13th power. Oh my God, definitely use your calculator. 4 to the 13th power, oh God, it equals that long number, times 5, it's going to grow quickly. 67108, 864, times 5. It's going to be, oh my God, this is a long number. 3, 3, 5, 5, 4, 4, 3, 2, 0, and I'm out of time. So what is that? 335 million